Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tier, where I'm running my feature on the Math Lovers book. And now I'm up to a new section, section 3.2, which is on irrational numbers. And I'm going to start with an introduction to square roots. Anyway, let's begin. So, like I said, we're starting a new section now, irrational numbers. Irrational numbers are just real numbers that aren't rational. And it turns out most real numbers are irrational, and there's a very precise way of defining what we mean by most. I'm not going to do that here, but it turns out if you just stuck a pin on a real number, it's virtually certain you would pick an irrational one, not a rational one. As a matter of fact, rational numbers are what are known as a set of measures zero, meaning the probability is zero of picking one if you picked one at random. But I'm not going to go into what that means. Just suffice it to say that most real numbers are irrational, even though the Greeks didn't even, originally believe that irrational numbers existed. As a matter of fact, they supposedly drowned this mathematician Hippasus at sea because he proved that the square root of 2 was irrational. Tough luck for him, I guess. But so I'm going to start with square roots. Square roots are a very important class of irrational numbers. And it turns out that the square root of n, if n is any number that's not a perfect square, like not the square of an integer, like 1, 4, 9, 16, 25, so on, as long as n is any number that's not a perfect square, its square root turns out to be irrational. And I'm going to prove that the square root of 2 is irrational, not today, but I think tomorrow I'll probably prove that. It's a very simple proof. This is the proof that Hippasus supposedly came up with that got him drowned at sea. Hopefully, I won't get drowned. I mean, it's been known for 2,000 years anyway, so I don't think there's any danger of that. But anyway, what can I say about square roots? I already said what they are, um, and now I'm just going to complete this video by there's a very useful algorithm, and I actually have a longer video on this. It's called Hero's method or Heron. There was a very famous mathematician named Heron of Alexandria, also known as Hero. He was famous for many things, but one of his biggest accomplishments was coming up with an algorithm for estimating square roots, and it turns out to be a very precise way to estimate square roots. And so this is what the algorithm says. So you start with a guess. I mean, if you want to, you say, try to approximate the square root of 2, you start with a kind of a reasonable guess. It can't be too far off. 1.5, 1.5 is a pretty good guess. And then once you have that guess, you can call that guess x. That's x0. That's the initial guess. X we can write for the square root of the number we're trying to calculate. And then once we have x0, that's our initial guess. Then we take the 2 and the n are the number we're trying to take the square root of, divide that by x0. That gives us a new number, which we can call y0 if you like. In this case, it would be what, 3 half? No, 1.5, 2 over 1.5. That's 4 thirds. So it's about 1.33. That would be our initial ratio. But then the next step is we take the mean, the arithmetic mean of x0 and y0. So in this case, that would be 1.5 and 1.33. That gives us approximately 1.41667, I think, as a fraction. I believe it's 17 over 12. Anyway, that's our x1. That's our next estimate. And then we just keep going like that. So then we would divide that into 2. That would give us 24 over 17. And then that's our y1. And then we take the arithmetic mean of x1 and y1. And I can't remember offhand what that is, but it's very close to the square root of 2. I think it's off only by 1 part in 10,000 already, just after 2 steps. So pretty remarkable that this, and it works for just about any number you want to compute the square root of. And you might want to check out my video on this. I actually do this in my head. I'm a pretty I've been a math prodigy my whole life, and one way I'm a math prodigy is I can do some pretty amazing calculations in my head. And I have, I think, 3 or 4 videos where I do several different types of mathematical calculations in my head, like multiplying two-digit numbers. I can actually do up to 3 digits sometimes. And also I can, like I said, I can apply Heron's method in my mind to calculate square roots of arbitrary numbers up to about three or four decimal places, which impresses a lot of people. And I could even calculate values of scientific functions, certain types of scientific functions for which I know the Taylor series, like trig functions or exponential functions, logarithms. I can do all that kind of stuff. Don't mean to brag too much, but you might want to check out some of my videos about some of the mental calculations I can do. But Heron's method is just one of them. So anyway, I guess that completes my video for today on square roots. So thank you for watching. Long live math, and I'll see you guys next time. Bye.